Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady, and today's guest is Whit Rawls. Whit is the sales engineer for Chase Corp's Zappa-Stewart brand of the Super Absorbent Polymers, better known as SAPs, and that technology of solidification type products. Whit's 19-year career in the environmental industry has been focused on water, wastewater treatment, bioremediation, heavy metal stabilization, and liquid waste solidification. He has a degree in chemical engineering and from North Carolina State University. Go Wolfpack, and is a licensed engineer. Whit, welcome to the show.
Thanks for having me, Sean. I'm glad to be here today.
Yeah, I'm glad you're here. We're doing a little bit of a vendor showcase today on this episode to showcase some of the products in the industry. And tell us a little bit about Chase Corp and the Zappa-Stewart brand of SAPs, if you could.
Sure. Yeah. Chase Corp's a specialty chemical company. We manufacture a wide variety of adhesives, sealants, additives, tapes, and waterproofing materials. The Zappa-Stewart business unit of Chase Corp specializes in manufacturing super absorbent polymers. So that's what we do at Zappa-Stewart, as all super absorbent polymers, which can be a few different chemistries.
Okay, so what if we break this down for the layman? What are the actual SAPs? What are they made of, and what are they typically used for? If you type use cases.
Sure. Yeah. So, if we just look at the super absorbent polymer business unit, it's also a very diverse group. We serve a lot of different markets, a lot of different applications and sectors. Super absorbent polymers are generally made of one of three different chemistries. There's sodium polyacrylate, there's potassium polyacrylate, and there's potassium polyacrylamide. And we certainly have business with all three of those. We have different customers that take all three of those chemistries. I would say probably somewhere around 90 to 95% of our business, though, is with sodium polyacrylate super absorbent polymers. And so I focus on the environmental sectors, which is a collection of different industrial sectors. You've got some experience with the environmental business yourself. We do a lot in the remediation business. If you think about maybe a chemical plant or a lot of industrial facilities that deal with water in their process, at some point will generate a waste stream that's generally regarded as a sludge, like a solid liquid mixture. All the water has been extracted from it that can be recycled for the process, and it's got to be collected, and it's got water in it. It can't be really managed, handled, transported, disposed easily or cost effectively. Whenever those types of what are usually called a sludge lagoon or a sediment pond, when those ponds reach their capacity, usually that company has to have that pond excavated, and that material has to be handled and transported and disposed in most cases. Our sodium polyacrylate super absorbents are very efficient, cost effective, safe for that type of procedure. If you think about it, an example would be a contractor, like an environmental remediation contractor would be hired to excavate a sludge lagoon. And then they've got to process that material, get it as dry as they can. Usually it involves putting the material on some sort of dump truck and hauling it to a landfill. It's not a very sophisticated process, but it's very important that super absorbents are used to eliminate liquid that would potentially leak on the highway, get onto public property, or cause environmental risks, hazards. The super absorbents used to make environmental contractors' job a lot easier, safer, and more cost effective.
Yeah, you mentioned the use case there with a lagoon, trying to finally or basically dry up a lagoon that had a little residual left. What are some other use cases that would be good for SAP?
Sure. Yeah, I would say the two biggest sectors that we supply our technology to are the horizontal directional drilling sector, which if you think about installation or construction of a oil and gas pipeline, such as, let's just say there's the Trans-Canada pipeline is a good example that I can think of off the top of my head. You heard about the Keystone pipeline in the news a lot years ago. When those pipelines are constructed, horizontal directional drilling technology is typically employed to create a horizontal bore under the ground surface to eliminate the need to trench. And that drilling process involves a slurry of usually bentonite clay, water, and some other types of chemicals that will keep that borehole open and stable during the construction of the pipeline.
Uh-huh.
And at some point, that slurry, that bentonite clay slurry, has to be collected, usually in some sort of waste pit. And that material has to be disposed of eventually at some point in the
Uh-huh.
process.
Uh-huh.
And our super absorbents are used heavily in that sector to quickly, efficiently, safely eliminate the free liquid in a horizontal drilling waste fluid application. It's been very successful in that industry.
What about, say, like in municipalities, wastewater facilities? Is there application there for that?
Absolutely. So, usually in a municipal wastewater treatment process, our products are employed when the municipality needs to, for example, shut down let's say, an anaerobic digester. It
Mm.
could be really a number of different unit operations at a wastewater treatment plant. But
Mhm.
for example, an anaerobic digester, municipalities got to go inside that vessel and replace some type of piping. And before they can even get to that, they've got to eliminate all this sludge that's accumulated in the vessel. And
Mhm.
so that sludge it's a solid liquid mixture. If it's placed in a truck and hauled down a highway, it's most likely going to leach sewage.
Yeah,
It's
right.
going to leach liquid out of the solid upon vibration and pressures.
Sure.
That's a very established application for our super absorbents, in which a contractor that's responsible for cleaning out that vessel they'll collect all the waste, the sludge, and any liquid they used in the process, and they'll just simply blend some super absorbent into that material, transform it to a solid very quickly, and place it on a truck and haul it to the nearest disposal facility. And the feedback we get from our customers in that business is they know our product works well, it's reliable, they know where to get it, it's always available, and we get it to them on time, and they know how it's going to perform, and it makes their job a whole lot easier.
Mm.
But yeah, definitely a good application for our products. And another one that I'd have to mention is the dredging industry. So rivers, lakes, sludge lagoons, like I mentioned earlier, that all kind of falls into similar category, in that a lot of the same companies are involved with doing that kind of work. And if you think about dredging river sediments, a lot of these sediments are fine particle size. You can dewater them only up to a certain point, and
Yeah.
then you just can't get any more water out of it at some point.
Right.
It's still
Right.
wet, and if you place it on a truck, haul it to the landfill or whatever that final disposal facility might be, you're likely to release some of that liquid during that transportation. And that's just not acceptable for that type of project.
What about, say, like a hydro excavation, like Badger Daylighting or Bloodhound Underground? These type of companies are just doing hydrovac type utility clearance type stuff.
Yeah, yeah. That's one of our very frequent day-to-day applications for super absorbents. Is those companies that you mentioned, they generate, well, probably thousands of gallons a day of
Mhm.
hydro excavation waste fluid, which has a lot of different kinds of material in it, but it's mostly water. Water's hard to deal with. It sloshes everywhere, no matter how much you've got. Water is hard to handle, transport, and that's a very good example. We've done some demos at hydro excavation sites where the contractor would just dump the waste somewhere in a pit and wait for it to evaporate. And usually we get the call after a while when they realize this is never going to
Taking
evaporate.
too long.
It's going to take forever, and we're running out of space on site.
Yeah.
We show a demonstration with super absorbent polymers. It does so much more than what I can do talking about it over the phone or in person. When someone sees how fast, efficient, clean, and easy,
It is
when
to deploy and take effect. It's pretty quick, huh?
absolutely, yeah, yeah. Those are the
So those are
big.
some of the benefits. Sounds like the benefits are it's fast, it's very efficient, and I'm assuming it's fairly cost effective.
That's right. Yeah. So it's fast. And what that means is, for comparison, an example of a material that we would typically compete against, for lack of
Yeah.
a better phrase, it'd be Portland cement. And so most folks in the environmental business know what Portland cement is, how it works. It's an ancient material. It's been used forever and still has plenty of great applications. But in a liquid waste solidification application, cement generally can take 24 hours to cure to where the material gets to a texture that is desirable and acceptable for transportation and disposal. For the same volume of, let's just say, a roll-off box full of, a hydro excavation fluid, for example. A super absorbent polymer technology can solidify a full roll-off box in 20 minutes. So you can go almost all liquid to a dry stackable solid that can be transported to a landfill and accepted in, any solid waste facility. 20 minutes is a ballpark. Sometimes less than that. Maybe it takes 30 minutes, but we're talking minutes versus days in some cases.
So what types of liquids aren't good to use with SAPs? I'm sure there's some types of liquids that aren't really amenable or ideal.
Absolutely. Yeah, sure. It is certainly low salinity water is the best fit for super absorbent polymer. And that's most water that we run across or that's going to be involved in an industrial process is usually going to be pretty low salinity. But if you think about salt water, seawater, if you had a dredging project in, say, the ocean, for example, that's going to be clearly very high salinity water, like 4% salt. And that would probably be a horrible fit for super absorbent polymers, at least sodium polyacrylates. And it's the process by which super absorbents work is an osmotic process. So if you think the sodium polyacrylate has a higher concentration of salt, fresh water has very low salt. There's an osmotic equilibrium reaction going on there. If the water's salty, there's little affinity or attraction between the water and the polymer.
Okay. What about other liquids, like maybe some organic liquids?
Yeah, if you're dealing with solvents, like high concentrated solvents, that's if it's water, if it's an aqueous solvent, it might have some chemicals in it. Usually it's no problem. SAP is usually a good fit for mixtures of water and other kinds of chemicals. However, if we're talking high concentrated solvents, likely not going to get a lot of absorbency from the polymer. Super extreme high pH, extreme low pH fluids, that would also negatively impact the performance of the super absorbent polymer.
So you need to know a little bit about the chemistry of the liquids before you select a specific SAP blend.
Absolutely. And in a consultative sales call with me or any of our salespeople in the super absorbent polymer business, those are going to be the first couple of boxes we check. And the conversation is, what's the fluid that you have to manage here? And the last thing we want to do is oversell our product and lead someone to believe that it's going to work on any fluid, and then the material shows up, a full truckload shows up on site, and it just doesn't work like to their expectations. So we like to make sure we understand what the fluid is immediately within the first few minutes of any conversation with a potential customer.
Yeah, I guess we're diving into a bit of my next question I wanted to ask you, which was like a little bit, what considerations should one evaluate prior to selecting a solidification agent?
Yeah. So some of those items that I just mentioned, the salinity, pH, the chemical makeup of the fluid. A lot of cases, in a lot of situations, that information is not available. So I always ask for it, but it's rare that environmental contractors have a salinity value available for a sludge. That's usually not a consideration. It's not a problem at most sites that we get involved with, but it's something that if you know that it's a salty waste stream, without even having the salinity value available, if you just know there's a salty waste stream, that's something we need to know, like a brine, industrial brines. Those are common in the oil and gas sectors. That's a good example of a situation where if I knew it was an oil and gas field where this contractor was working and he needed to solidify some fluid, I would real quick get to that point. Is this a salt base? Is it a high salt concentrated fluid that you're dealing with? Because we want to make sure that there's a good fit there. The pH, the chemical composition of the fluid, Some other considerations are what the disposal requirements are, which are typically established by the landfill owner, landfill
Mm-hmm.
manager, which is a few companies, a couple of really big landfill management companies in the US that we work with that manage a lot of the big landfills. And they often have compressive strength requirements
Oh.
for waste. If it's a waste stream that is known to be wet, so
Mm-hmm.
wastewater treatment sludge, dredge sediments from a river, when the contractor and the engineering firm are having discussions with the disposal facilities early on in the process, that's something they're gonna figure that out pretty quickly. Understand that if there is an existing compressive strength requirement for this particular waste stream, this particular project, and often that's based on not only is it a wet waste, but how much is there? If it's a small amount, there
Probably
may
not a
not
big
be.
deal, but because
Yeah,
they can handle it with the other solids in the that they receive in the landfill. But yeah.
sure. Let's say you're dredging one of the Great Lakes. You're generating just astronomical, staggering volumes of wet waste.
Mm-hmm.
That's probably going to be a detail that would be discussed at least. It may not be a requirement, but the compressive strength is something that I would say, like maybe half of our projects. It's an issue, it's a topic that we address very early on.
Touching on that, do you have specific blends that can achieve a more stable compressive strength versus maybe just a lower level absorbent version of the SAP?
First choice would be certainly the minimum dosage rate possible. If you can get by with the smallest dosage rate that
Mm-hmm.
we can demonstrate in the lab that it eliminates the free liquid, that's the best strategy for meeting compressive strength requirements. We do have some bentonite SAP blends that tend to offer a bit more compressive strength.
Mm-hmm.
We have some wood flour, which is like a fine sawdust. We have wood flour SAP blends, which tend to offer a bit better compressive strength and compaction.
Mm.
But yeah, those are the ways that we can help work with that requirement, because
Gotcha.
the super absorbent polymer, when it's hydrated, when it does what it's supposed to do and it does it so well, it does have a soft texture. So it's, if you ever see that material when it's wet, when it's hydrated and done when it has done what it does, you're not going to get it. You're not going to increase the compressive strength of anything with that. So we
Mm-hmm.
certainly do have to minimize the dosage rate and or look at some of our blends. There's also super absorbent polymer does work pretty well with cement and lime. So there is an opportunity in some cases where this can be used in series with pozzolanic reagents like lime and cement, where they offer both products can offer their features and benefits to the project.
Gotcha. I'm thinking like, okay, I'm a contractor. I'm out on emergency response spill. I'm trying to deal with stuff and clean up some liquid waste or liquids that were spilled. What types of, I guess, applications or how are these things actually like mixed in the field? Because if you got to think through like, how am I going to solidify this material? Sometimes it's not just ideal to have it in a tank. So how else can they mix this stuff up
Yeah.
and solidify?
So usually waste material that's going to be treated with super absorbents or something similar, usually it is contained in some sort of uh,
Yeah.
vessel, whether it's not, I would say it's rarely in a tank. It's some sort of pond, a defined lagoon, pond,
Mhm.
basin, something like that, or a roll off. Some of our contractor customers do capture waste fluid in roll off boxes, knowing that they're going to already have the material in a nice, they know the volume, how much
Yeah.
SOP they're going to need. That's usually the setting. If you think of some sort of pit, whether it be a concrete pit in a waste treatment facility or a open earthen basin at a construction site,
Uh-huh.
in most cases, they're using an excavator or a backhoe. It's called bucket mixing. So the
Yeah.
SAP can be applied. It's a pretty unsophisticated, honestly. We have super sacks that can be opened and
Spread
essentially,
out and sprinkled across the area.
yeah, it's cool to be on site and watch one of those operators when they can take a super sack, which is about a ton. They can connect the super sack with their lifting straps, hang it from the excavator bucket, and open the bottom. It's got usually it has like a valve that can be opened and tied back up. So they'll open it up just enough so some of the SAP starts to come out of the opening, and they can broadcast and swing that bag over the lagoon, and so that they can broadcast that sludge and get even distribution. So then once the SAP has been applied to the sludge, typically, depending on the moisture content, they're going to have to use that excavator to stir. They're going to physically mix the SAP into the waste.
Mm-hmm.
The main requirement for super absorbent polymers to achieve their full potential at a solidification site is to get thorough mixing within the material.
Right.
The SAP crystals, they have to come in contact with the water. And once they do, it's an immediate reaction. The water is drawn into the crystal structure of the super absorbent.
Mm-hmm.
And if you think about a solid liquid mixture that has, if it's got a high percentage of solids, the solid, let's just say it's like a soil particle, essentially, that particle will get in the way, get in between the water and the super absorbent. So that's why the mixing is required to make sure. If you think about making pancakes, it's very similar. You don't want white flour in your pancake mix, right?
Yeah, you got to mix it thoroughly. Once it's done, then it mixes around and starts to take action. And you can probably see it, like you said, probably really fast. It sounds like so.
You can, yeah. It's a
pretty cool situation when you start seeing like, wow, okay, we just absorbed this and solidified this whole area in about an hour.
right.
Like,
yeah, it's still fun. I'm still intrigued and mesmerized when I go out to a site and I see the stuff every day. I've been selling it for years, and every time I go to a site, it's still fun to watch an operator get that work done in a fraction of the time that he was expecting.
Mm-hmm.
Or if you'd used something else, it would have taken a lot longer, and it just makes life a lot easier. But yeah, you can see it happen. You can see the reaction taking place. You can see the material going from liquid to solid in real time, right? You can just watch it happen, and it's pretty cool.
Well, what are some of the benefits of using SAP compared to other types of solidification agents? Because you talked a little bit about bentonite slurry and other products out there, sawdust. There's all kinds of different types of agents out there. Give us a little bit of some of the more effective benefits of SAPs compared to some of those other alternatives.
Yeah. So in addition to the speed factor, which SAPs, they save a lot of time on site, but I think the most important, the leading benefit of using super absorbents versus other solidification media is the efficiency and the absorption capacity of the super absorbent polymer. So sodium polyacrylate super absorbents will absorb anywhere between, depending on the fluid being absorbed, 250, sometimes close to 400 grams per gram. So what that means is, let's just say 300 is the number. 300 grams per gram means 300 grams of water absorbed per gram of super absorbent polymer. So 1 gram of super absorbent polymer can absorb 300 grams of water.
Wow. Yeah, I mean, so it sounds like you don't need a whole bunch of this polymer.
That's right.
Volume wise to really make a difference and quickly.
It's very effective at extremely low dosage rates because of that tremendous absorption capacity. It can be difficult to fully embrace or fully appreciate and grasp that absorption power, if you will, unless you see it in real life. I think it's counterintuitive. It just, if you're used to, let's say you've been a construction contractor for many years, you've used cement, you've used lime, you've used fly ash, you've used wood pellets, sawdust, whatever, any of these materials, you have an idea how much it takes to dry out a certain volume of waste material. And so it's one way that we can compare apples to apples in this particular conversation on this parameter on the absorption capacity is to look at the dosage rates that are typically used for super absorbent polymers versus other reagents. So super absorbent polymer is usually applied anywhere from 0.5%, but sometimes even less than 0.5%. But most of the time, it's somewhere between 0.5% to 1% by weight, which is small. That's a tiny dosage rate.
That's a lot. Yeah, it's very small.
So, for comparison, Portland cement, lime, used for similar applications very frequently. Dosage rates can be anywhere from 5, 10, 15, 20, 25%. It can be unpredictable, but usually we're talking double-digit percentage points for dosage rate. So what that translates to for an environmental practitioner, a remediation professional, someone that's responsible for managing a large volume of liquid waste, is you're going to be really concerned with the weight that you are hauling and disposing at the landfill. So a landfill is going to charge a tipping fee per ton. That could be $200 per ton in a lot of regions of the US. So if you are already starting with a known volume of waste, let's say it's tens of thousands of tons of waste material that you're excavating, managing, hauling, disposing of, you're going to already be billed for all that. That's for sure. But then the more material treatment solidification media, the more of the solidification media you add to the waste, we're paying for that too. You have to pay for that weight.
You could increase your disposal cost by 10, 15, 20% with another product versus you just mentioned it's what, 1%?
Right.
That's where it's like completely almost negligible compared to the original volume you had. So
Exactly.
that is a big cost savings and a major, I would say, consideration for using SAPs. That's
Absolutely.
makes it totally like common sense. Let's call these guys.
Yeah. And to dig a little deeper on that topic, if we're talking about hazardous waste, TSCA waste, anything that requires special disposal facilities and handling, well, the costs go up even more. So I think hazardous waste is roughly 3 times, like the tipping fees, I think are 3 times, or trans and disposal costs altogether, ballpark 3 times that of non-haz waste. So, and usually there's significant transportation charges involved with that because there's only a handful of facilities.
You're going a little further away typically because there's not as many facilities locally. Yeah, for sure. That does make a lot of sense. And so that would be a very strong consideration of why you'd want to consider SAPs versus these other types of products. That's a great point. I'm glad we discussed that. Where do you guys manufacture this product? Where is it at? How do you store it? Where's it at? Where do you guys do this at?
Hickory, North Carolina.
Hickory, North Carolina. Okay.
That's where the material's manufactured. We have a significant grinding and sieving operation in Hickory. We have significant warehouse space in the Hickory area where everything ships from.
Wow.
We have lots of different kinds of super absorbent polymers in different packaging. And that's where it all comes from.
So maybe you're just a contractor, you need some, like what's the smallest volume that you guys would entertain as far as sourcing out to a customer? And then like normal sizes is maybe what, a tote size or what? Or what are we talking about?
Pallet. So usually, we have some customers that they may need half a pallet. We'll sell half a pallet. And when I say a pallet, that's 40, 50 pound bags. So 2,000 pounds is a full pallet.
Okay.
Full pallets, full truckloads, which is 20 to 21 pallets or super sacks. So you can buy one super sack on a pallet, or you can buy 40, 50 pound bags on a pallet. And then, the full truckloads would be 20, 21 pallets or super sacks. Most of our business is certainly with the larger orders, full truckloads, but a significant remediation solidification project for us would be something along the lines of, let's say 5 to 10 truckloads. Those are pretty routine. 5 to 10 truckloads, projects going on for a month or two. We have one now that's a 6-month opportunity, and it's like a truckload every week. But we also sell pallets, and we can, if somebody's got a need for a specific amount, we'll sell 50 pound bags sometimes, depending on the opportunity and who the need immediate.
Do you guys do treatment studies or anything like pilot study type stuff for people that are just wanting to test it out a bit before they write it into their remediation plans or some other programs that they were working on?
We do. Yeah, absolutely. So that could look a number of different ways. At the very least, if we're discussing a significant solidification opportunity with a customer, we like to get a sample of that liquid waste, sludge, mud, slurry. We like to get a sample sent to our lab in Hickory, where we can conduct a very simple, in most cases, complementary solidification study, which almost always just comes down to determining the best dosage rate. So you think about a 10,000 ton project, the difference between 0.5% and 1% is tremendous. That's doubling the volume of super absorbent. If we can show that this waste that you sent us I was able to solidify with 0.5%, that gives that customer some assurance that the waste and the super absorbent treatment media are compatible. It's a good fit there. It can also gives that contractor some guidance. They can hit the ground running. They already know, we're expecting to use about 0.5% by weight. There's always some optimization in the field, no matter what we do in the lab. There's always, they get out in the field. Hey, they might call me the next week and say, you know what, we got the dosage rate down to half or to quarter, 0.25%. And that's great. It's less material sales for us, but we have a happy customer and makes them more likely to continue wanting to use super absorbents. So that's one way, is to have a sample sent to our lab where we can evaluate in the lab. Another, which is one of my favorite methods, is to go to the site. If I can go to the site and meet the contractor on site, I've got a solidification test kit that I take with me to job sites, and I get a sample of the sludge right there on my tailgate, and I'll have scales on me, and I can determine
what the blend ratio should be, and there you go.
Right there on site. And that works the best because typically all the people involved in that project are standing over my shoulder.
Yeah, I can see the capability of the product and go, wow, okay, yeah, this is going to work great, and move forward pretty quickly.
Yeah,
get buy-in.
Manager, the foreman, the excavator operator. If I can get all those individuals to buy into the super absorbent product, then it's just going to be such a smoother process.
For sure. So it sounds like there's some really good case studies. Any particular case study that comes to mind, you're like, this was a really great outcome for the use of this product that you want to share with the listeners real quick?
Sure. Yeah. I'm going to have to keep it confidential, but I can, give some useful information so you can understand what type of project it is. And we had a lake dredging project in the Great Lakes last summer with a pretty big dredging contractor. It was a mechanical dredging project, which is important. That tends to be our best fit in the dredging business, is if it's a mechanical dredging project. The other product that this contractor was considering was Portland cement, and they've got loads of experience solidifying dredge sediments with Portland cement. But they had used SAP before, and they knew they had some good experience in the past with it. This project was very successful. I mentioned a little while ago that sometimes my customers dial in that dosage rate a little bit better once they get in the field. That's what happened here. The contractor had bid the project with an assumption of 1% dosage rate of super absorbent by weight, and got in the field. And after a few weeks to a month of optimizing their process, they determined that they could fully solidify the sediments with 0.5%. So that cut the amount of SAP needed from 10 truckloads roughly over a 3 or 4 month period to just, I think it was five truckloads. It's 44,000 pounds per truckload, 20 tons of super absorbent per truckload. One way to look at it is, man, we missed out on a lot of super absorbent polymer sales. However, we also have a really good customer that just had a very successful project, and they capitalized on that success and won another project that starts next year that's probably 5 to 10 times bigger than that one. And they're anticipating using SAP on that project too. And there were some pretty big stakeholders involved in that Great Lakes project that also are now proponents of super absorbent polymer technologies. That one, for me, that's the most recent big success.
Oh, that's great. That's an excellent case study and a good summary of the benefits of using it and the potential cost savings. That's great. And you guys sound like a great vendor to work with. And I typically do a bit of a lightning round with kind of a couple questions and then we wrap it up. But what are what's like the biggest misnomer about SAPs? People might not.
It's expensive.
They think it's expensive. Okay. Yeah. All right.
It's expensive. And then here's why. If you took a handful of super absorbent polymer and a handful of sawdust, and if that's how you're looking at it, it's going to be really hard for you to see how super absorbent polymer is not expensive. However, sawdust can be free. It's free in a lot of cases. So our product range has a wide range of prices, but It's a lot more than free. It's a lot more than a lot of materials on the market on a per unit basis.
Mm-hmm.
But that's when we go back to the absorption capacity discussion. If you were to use sawdust, usually you're going to have to apply equal amounts of sawdust to the amount of waste that you have, if not double in some cases, even if it's half as much. If you can imagine, that's a lot of volume also. The volume equals more trucks, and you're adding a lot more weight to the overall waste. So you got a lot more trucks that you're having to pay for.
There's labor too, right? Construction labor of applying the material, trying to process and get it, solidified. So that would be a cost savings as well, it sounds
If we had a few more hours to talk about this, we could go into all the aspects of the project where I can say, look, here's another place, here's another line item that you're going to save a lot of time and money on.
Sure.
For sure.
Yeah, no, I think once the customer gets over the cost factor and really drives down to the value aspect of it, they're probably going, okay, this is a better deal. And now I understand why. So it makes it a no brainer, but you probably got to get them there with a little bit of a conversation first, right?
Absolutely. Lots of quality directed questions and understanding all their metrics and what their requirements are at the landfill. There's a few things that we need to know beforehand. And I go into every project confident that our product, our technology is going to save time and money for a contractor engineer. Now, I'm sure there's a situation where, okay, they might prove to me that in this particular case, we've got free material that we got from the plant next door, whatever it is. Okay, maybe. And maybe there's a very strict compressive strength requirement, and maybe it's not a good fit for super absorbents. Rare where super absorbents aren't the best choice.
Yeah, no, that sounds good. What are the top 3 industry type customers for you?
I would say number one is typically a large environmental contractor that is typically hired by one of the bigger engineering firms to implement a work plan. The engineering firms are one of the other big customers for us. In a lot of cases, we're working with those engineering firms to have super absorbent specified as the reagent of choice, so that the owner, the site owner, who is that's the other typical customer of ours. I mean, we're not selling material to a site owner, but that's clearly, if you can get the site owner to buy in, it'll be a lot easier process for you. We want to show all of the stakeholders that this is going to save time, money, risk. And so we have to appeal to all of those entities. The contractor that's who we're usually dealing with on a day in and day out basis. They're cutting the check to us. That's who we're shipping to, and that's who I'm helping them to understand if there's any kind of troubleshooting that needs to be done in the field. But the engineering firms are critical in the process, because if we can appeal to them and show, look, this is really going to in your client's best interest. Here's why. It's if we can get the engineer to buy an SAP, that's going to help everybody out tremendously.
Absolutely. Yeah, I can see that. Anything in the transportation arena, building roads, bridges, any of those kind of guys are targets for you guys?
Yeah, sure. I mean, we've got some construction contractors in the Pacific Northwest that are, they're doing civil construction. They're not environmental contractors. They've got so much wet soil, just wet conditions, that they'll keep super absorbent polymers in their shop, keep it on the truck, because they know there's a good chance they're going to encounter just a sloppy environment where hey, this is not going to work. We got to have something quick. What are we going to do? Well, we got super absorbent in the truck. It's going to be an easy fix. And another one that's a newer application is thermal remediation sites, where they've got these electrodes installed into a contaminated aquifer. A lot of times those sites, if there's a lot of rain, they've got standing water throughout the site. And so that's a more recent application for us, is providing those companies with super absorbent for just quick mop up work, almost just like eliminating standing water so they can get to their job. A lot of what we do is helping our customers eliminate an annoyance, eliminating a liquid that's just, can we get this out of here so that we can do our job? And that's a lot of times that's where we come into play.
That's awesome. That's great. And I think this has been a pretty good conversation around super absorbent polymers, SAPs. A lot of times we have so many acronyms in the industry and you're like, SAP? I thought that was a computer program, but no, that is one, but that's not what this is. This is a super absorbent polymer type solidification compound that really makes a big difference. And so, Whit, thanks for coming on the show. As we wrap up here, how do listeners get in touch with you and learn more about SAPs?
I would say probably the best way is to send me an email. Do you have a way to display my email address?
Yeah, you just want to tell us what it is, and then we'll get that on there. Yeah.
Yeah, sure. It's W Rawls, so WRAWL as in Larry, S as in Sam, at Chase Corp, ChaseCorp.com, chasecorp.com.
Great. And then is the website just chasecorp.com?
It is. And
you
can get to us that way too. It might take, it's a little bit more, you won't get to me as quickly, but ultimately it'll inquiry.
Yeah. We'll put a link to your contact information on the website. So all the listeners can go to my website if they didn't catch that and grab your contact information off your bio and your profile on my website. So Whit, hey, I really appreciate you coming on the show, talking a little bit about SAPs and what you guys are doing at Zappa-Stewart and the Chase Corp. Really appreciate it.
Sean, I really appreciate the opportunity.